Hello and welcome. I'm Nick Gibson and I'm joined by Lane Nott, Director of Engineering at Hypertunnel, who are using metaverse technology in construction and repair of underground structures. Patrick, welcome.
Thanks, Nick, for having me. It's great to be here.
So, the industrial metaverse, what is a digital twin?
Well, it's a very good question. And I think if you ask 10 people, they'll give you 10 different answers. But I think certainly my answer, digital twin, probably comes or harks back to my previous role. I used to have, I spent quite a lot of time in motorsport, sort of high-end echelons of Formula One and the like. And we were using digital twins, although that sort of phrase hadn't been coined as such. Well, decades ago, really, just developing the race cars to try and make them go as fast as possible. And one of the big drivers for that was the fact that the track time was very, very limited. And so the way that you wanted to do that was creating simulations. And as the technology improved and the cost of computing came down, obviously that activity got more and more prevalent, and also the legislation within the sort of regulations of the sport also drove it. And so we've been using digital twins for quite some time, as I say, being able to do simulations of the car itself with specific conditions and tracks, but also for driver training and driver sort of familiarity of tracks. Again, just to maximize the amount of work you can do at the track when you get there, because the time on the track is so precious. So from that perspective, I think my experience is definitely driven from that, and what I'm trying to do is to bring a lot of what I've learned in that world to the construction world, and specifically underground construction, where I'm working with the team here at Hypertunnel.
So it's quite a leap from F1 to burying yourself underground, but certainly in talking to a number of people, it seems that the construction industry is lagging rather far behind in the use of digital technologies.
I think I'd absolutely agree, Nick. I think there's obviously, it's a very safety conscious world, the underground construction world. Like many industries, obviously safety is very much at the heart of everything that's done. And so a lot of the techniques are sort of underwritten by the fact that they've been done like that way for so long. And actually, there's a lot that can be improved and made safer by using the digital tools that we now have available and are very easily accessible to anyone, really, with even as simple as a smartphone or a laptop. You can start using the digital tools at your disposal to help that situation significantly. So I think, yes, it is a big jump from the F1 world, but I think there's a lot that the construction world can learn, because in reality, specifically for tunneling, if you look at the tunneling machines of the current era, they haven't really changed much in the last sort of 100 years. Yes, okay, they've got a few more sensors, and obviously they're a lot, I guess, more fit for purpose, but they have sort of reached their limitations, and there's actually better ways that you can actually tunnel in the ground and sense and understand more about the ground than that we're currently doing. And that's certainly where we want to move into, and that's certainly where we see the metaverse as it's coming on and as it's being progressed. Because I think certainly from my experience in motorsport and more latterly in the automotive world, I think that the use of interactive tool sets in the digital world has been in those other industries for many years, and a lot of that is probably driven, in my experience, because a lot of the sort of different parts of the project are all using the same piece of software, so they can interact quite easily. So when one of the big car manufacturers is developing a new chassis or a new platform, all the different elements, from the drivetrain to the bodywork to all the different elements of the vehicle, can all be working from the same piece of software and CAD, and they can make sure it all works and share that data. Whereas in the construction world, it's very different, because you normally have consultants and contractors and all the different people that turn up on site to do a project on a given day are all coming from very different places and with very different aims. And so they have different tools, different pieces of software. And I think one of the critical difference is there is because there's so many players within even a very small project. It really does provide a bit of a jam with regards to sort of sharing data and information, which I think, you know, BIM has taken some steps towards trying to bring that sort of information, sharing it widely, but I just don't think it hasn't really been fully adopted, partly because it's quite static, and it's not particularly intuitive. And I think there's better tools that available now that the construction industry can use.
I was going to ask about the connectivity, because it seems that people have been talking about maybe trying to develop a new open architecture which basically can handle all the various interconnectivity issues, and the fact that no matter what industry you're working in, you're taking in feed information, data from all kinds of different places and software platforms, quite often to all kinds of different formats. Is there a sort of common platform and standard and for interconnectivity, or is it still a question of integration?
Well, I think that the tools of the current world, you're right, a lot of it is adapters and interfaces and all that, and that's even in the mechanical world. Interfaces is normally where the problems lie, and that's still the same in the digital world. I think being able to manipulate, analyze, process data in a simple way and move from one company or one consultant or whoever's using the data to another is absolutely key. And so some form of common platform would be useful. Obviously, there are a lot of common formats already in the sort of CAD world which are shared, but in general, it's not always convenient. You quite often lose data and you transfer from one to the other. So I think certainly if you were to try and paint the ideal metaverse, you'd have a situation where all of those sort of problems went away and you could just all be using the same format in the same world, and it all sort of slots together nicely. I mean, I think it's quite a lot of hard work to get to that point, but I think it is possible. But I think that obviously that does mean a fair amount of compromise on various different aspects, because everyone always has their favorite tool and they want everyone to use their tool rather than the tool that the other is using. And so there's always that challenge. But I think if the metaverse turns out to be what it could be, I think that a lot of those problems would go away, because the utility, the usability of it will be so much greater than the current methods.
So apart from interconnectivity and the various format wars that always go on in the Wild West, is there enough physical power, either bandwidth or energy, to realize the full potential of what might be available? Because I mean, the bigger kind of machines that you're starting to build in the 3D world and virtual world, and more collaboration that you're doing, surely it needs more power wherever it comes from.
Yeah, potentially. I mean, I guess it depends how dynamic those environments are and how many people are in a given space. I mean, you only have to look at the gaming world to realize that it's very easy to create worlds that literally hundreds of thousands of people can inhabit quite happily and be unaware of how many others are in this space, because it's all rendering and working as they would want it to. So again, a lot of that will obviously depend on where the processing is done and how you're transferring the data. I think certainly in the metaverse of the future, there will be a fair amount of data flying around for sure. But I think that there are ways of using the data and processing the data in more efficient ways. And again, that's improving all the time, where you don't necessarily have to have the data rates that are necessarily being recorded or being produced. You don't have to have the data. You don't have to consume the data at the rate that it's being created. So I think there's certainly efficiencies that can be made around there, and that's the same in the rendering world as it is in any sort of data analysis. Again, back to my racing days, when in the early sort of format, when telemetry and that sort of thing was the bandwidth was limited. Certainly we would have the core information at very a good refresh rates, and then we'd record all the sort of fast stuff on board the car, so that if there was an issue or something, you could then look at that later on. And I think that's certainly, that edge computing is still, well, it's potentially one of the ways that we can get around some of those bandwidth issues.
So what you're doing at Hypertunnel is new. I've been speaking to people in the overground construction business who say there's an awful lot of education needed. We've always done it this way, so all this kind of stuff. Pioneers tend to be the people walking around with the arrows sticking out of their backs. Is it an uphill battle in order to convince people of the benefits of what you're doing, or can people see it straight away?
It's interesting. I think in general, I think the industry response to what we're trying to do with digital twins and with swarm robotics to improve the tunneling methods, and indeed we've come up with a fairly innovative way of tunneling that is faster, cheaper, and safer than the current methods. But I think the industry itself, rather than sort of pushing back, is actually embracing, and I think that's really refreshing. They can see the benefits that what we're suggesting and how it potentially can improve the processes and in reality, move the whole industry on significantly. I mean, I think if you look at other industries that are very safety conscious, things like the automotive or the aviation world, they've actually grasped technology and moved the industry forward massively. And I think the tunneling world could really sort of take a leaf out of both of those industries' books, because if you'd said sort of 30-40 years ago we'll be gluing planes together, people would have thought you were mad. But that's what they're doing on a day-to-day basis now. In the same way, in the banking world, if you'd said to someone, I'm going to give you some money by pressing a button on this phone I've got in my pocket, they'd have thought you were some sort of crazy person. So I think the industries and all these industries have really grasped it. And I think the construction world, there's a lot to be a lot more progress still to make. But the good news is that I think that everyone's ready for it and they really want it to happen. That I think that the difficulty is really making sure everyone is moving in the same direction rather than in lots of different directions.
Well, common standards, etc., common platforms, common formats, common interconnectivity is going to help enormously because there is so much involved. I mean, going back to the beginning, when you were first looking at these kind of 3D simulations and all the data involved, did you have to invent your own software programs and platforms? And indeed, what's the situation now? Is there things you can take off the shelf, or are you still having to customize your own solution?
It's an interesting question. I mean, in general, Nick, obviously as a startup, we were trying to do things in an efficient way, and a lot of the hardware that we started off with was off the shelf, and over time that's developing into very bespoke elements that are doing exactly what we need once we've done our sort of proof of concepts. And I think the same is true in the digital world and in the software side. I think we've initially looked around to see what tools were out there that we could use that would get us on the journey, and a lot of those did some of what we need, but not all of it. But it was enough to get us going. And now we're in the process of doing a lot of that sort of bespoke work. Some of it again is around the interfaces, of course. Some of it are sort of add-ins and bolt-ons to existing pieces of software. But I think, as ever, whenever you're doing something slightly different, you're always going to have to create some customers, and that's obviously where the innovation is happening, is bringing that together. But in general, a Hypertunnel, we've always tried to not reinvent the wheel where we don't have to, because there's not enough of us to be able to reinvent and do everything from scratch. So we're just focusing on the bits that are going to add the best value and create the best products in the end. So that's really where we've been focused.
So these technologies are developing all the time. The application of these technologies is also developing as people come to realize more and more ways they can benefit from it. You've been in this space, so to speak, above ground and below ground for quite some time. So where do you see things going in the future? Is there one or two things that would really make a difference, or is it just a matter of developing what's already there?
Well, I think certainly the sort of further adoption of digital and data, in essence, I think the certainly in the industry, there's a lot of sort of empirical. You have to do physical tests to be able to believe that something's actually true. And I think that sensing technology is at a place, or very close to a place, where you could actually rely on sensed data rather than physical, destructive data. In a construction world, you might want to take core samples and do sorts of compressive tests and that sort of thing. Whereas, what's stopping you from doing a whole bunch of non-destructive sensing on that to be able to come to the same conclusions, if you have enough data to back your argument up? And I think that's a lot to do. A lot of that comes in with the sort of machine learning and the artificial intelligence, where you can use what's gone before to help you make much better decisions in the future. And I think that's really the area where there's the sort of potential for growth, and for making the processes more efficient. I mean, obviously, there's tools that are already around, the sort of virtual realities and the augmented realities and all this sort of stuff, which again would be very powerful tools. If you think, the virtual world we've already talked about with the gaming and that sort of thing, but the augmented reality where you are on a job site, and then you could potentially put a pair of some sort of goggles or glasses and be able to see another layer or some digital information that makes your job easier, then that's obviously a massive step forward. What we want to do actually is go the next stage and almost take the human out of it and automate the whole process. So, I talked before about our swarming robots and be able to let the swarming robots take the decision. I mean, obviously that's quite a way down the road. We've got a little bit to do before then, but there's no sort of reason, technological reason why we can't actually do that. It's just a case of getting enough data and amassing enough data and refining the processes so that we can get to that point where you can digitally sign off something that's been constructed underground in relatively conventional methods, in that you're still putting structures into the ground, but the way that we're going about it might be slightly different. At Hypertunnel, we are, as I say, using swarming robots to place construction material into the ground, like 3D printing, or akin to 3D printing, and that way we are able to have much more control about what's happening where and when, and all of that can be recorded and analyzed in the data. But obviously, because it's underground, you can't see what's going on, so you need to have some input, or at least be able to understand what's happening at any given time. And that's obviously where some of the virtual and augmented tools can really come to the forefront, where you're either troubleshooting or you're just monitoring. And I think that's certainly where we're going to come as robots become more mainstream in the construction world, and whether it's robots or cobots, either or. I think there's already a lot of work being done by them, and we at Hypertunnel believe that that's going to come a lot quicker than maybe a lot of people realize, because of the conveniences and the efficiencies and the economies of scale. If you're starting to use hundreds or thousands of small robots to do the job that traditionally one giant robot, and when I say in tunneling world, that would be a tunnel boring machine, which is a large robot, albeit there's people driving it. By having lots of small ones do the job in a maybe a slightly different way, your level of redundancy is infinitely better, because you're not beholden to a single failure that would then potentially delay the whole job for a period based on something could be very simple. I don't know, an O-ring seal failure or something like that may bring down the whole machine for a period. So there's lots and lots of different layers, not just with the data, but also how you're processing, how you're monitoring, and how you're realizing the space, and being able to use the digital data and information to make good decisions all the way through the process. So that, again, we're looking to do a whole bunch of surveying before we get into the ground, so we understand exactly what's going on in the ground. We then record through our deployment process as we actually build the structure, and then all of that gets captured and then is used in the sign-off at the end of the construction process. and we can bundle all that over together and hand it off to the end operator of the asset. So let's say it's a tunnel. We'll pick the easy one. If you hand that off to your customer at the end, and they have a fully working digital twin which they can run simulations of all sorts of unforeseen events, they can then work out the best way to react to those events, whether it's something that's happening in the ground, some seismic event, or something similar, or if it's actually, you think some of the structures we're building now will still be around in 150, 200 years potentially, and so the chances are that they will change their use. And having a full digital twin of an understanding about how that tunnel was constructed, when you want to change from, I don't know, a railway to a hyperloop system in 50 years time, wouldn't it be great to know exactly what's going on in and around the tunnel? And of course you can get that by having sensors in the ground, and all of that IoT technology is already out there. That can all be fed into your digital twin to give you live feedback of exactly what's going on, but also to be able to help you to predict maintenance and or future proofing your asset, making it as smart as it can be, which again, the technology is there and it's simple and cheap. It's just got to be implemented.
Patrick, you're a man who knows his onions, and I, for one, recognize that robots are indeed the future, but on this occasion I'm most pleased and glad to be talking to a human.
That's fantastic.
So thank you so much for your time, Patrick. I do appreciate it. This is clearly an area of technology that is going to become the future. So and you, I'm sure, will remain, as you have been for many years, a key part of that. So Patrick, I thank you for your time.
Thanks very much, Nick. Great to teach you.
There you go. I've stopped the recording now. Oops, I have now.